Hi, my name is Russ Westphal, and I'm a professor of mechanical engineering here at Cal Poly. I'm also the director of the Boundary Layer Data System Project. The Boundary Layer Data System Project seeks to measure the features of boundary layers on aircraft in flight. This summer we hosted 3 students from the College of Engineering's summer undergraduate research program as part of our team. These 3 students are here today, Andy, Luke, and Rachel. And they're going to tell you about the work that they did in support of the project. Andy?
So my project over this summer was creating a hardware system that could measure static pressure fluctuations with a MEMS microphone here. So over this summer, first what I had to do was I had to code a program that would allow us to sample at 94,000 times per second. Next, I had to calibrate this same microphone in an acoustic sound field with a reference microphone to make sure that this MEMS microphone was working up to standards. Next, we ran wind tunnel tests on the whole setup to make sure that we could actually measure static pressure fluctuations. We do this in the hopes of eventually measuring an acoustic sound field on a real flight test.
Hi, I'm Luke. This summer, I spent my time designing new rigs for the boundary layer data system. This is our current rig. It mounts on an aircraft surface, and it's used to measure boundary layers. The characteristics that I was looking for in our rig designs was to make a rig which could be quickly manufactured, as well as rig designs which could be configured to measure different boundary layer thicknesses. I also was able to manufacture these rigs using our 3D printer here in the lab. In addition to that, I also conducted wind tunnel testing, such as the tunnel behind me, to evaluate several different design characteristics for these rigs.
Hi, I'm Rachel, and for this project I designed a silicon manifold that would replace the current aluminum manifolds on the BLDS rake. So first I took a casting approach and I designed the outer portion of the mold that was 3D printed, and then I used brass and stainless steel to comprise the inner workings, and then I got this manifold which I then attached to the outer centers and performed leak tests. And once I found a manifold that passed the leak test and fit the sensors accurately, I used those dimensions to create a design that could be directly 3D printed. And I 3D printed 2 different manifolds, and I found that the more accurate printer was accurate enough at a smaller scale, and that printer could be used with a silicon-like material in the future.